Let's look at an SAD example for dose calculation verification, or MU verification. This is a 100 centimeter SAD example. I have APPA with a 10 by 10 field on either side, equally weighted. I get this hourglass shape as previously discussed. I normalized at 100%. If I go to my report, field 1 is the anterior 6x 10 by 10. You can see the treatment planning system says 128.3 monitor units. My calc point fractional dose, since I'm equally weighted, is 100 centigrade. The point SSD is 89.6 and the depth is 10.4. These two are important. Number one, it tells you what the inverse square law is going to be. Remember, inverse square law is going to be source to calibration distance divided by source to point distance. Well, the source to point distance is found out by adding these two together. Because this is a homogeneous calculation, we're not going to worry about equivalent path length, even though it reports it regardless. So if you add the two of these, 89.6 and 10.4, you get 100. Well, my machines are calibrated to deliver 1 centigrade per monitor unit at 100 centimeter SSD plus D max, which is 1.5 for 6x. So source to calibration distance is 101.5 divided by source to calculation point distance is 100 squared, 103. So my inverse square factor for this field is 103 based on this data. Now field 2, we can get similar information from. 6x, I have 10 by 10 field size for my jaw settings. It gives me what the treatment planning system reports for monitor units, 129. I get my fractional dose component, 100 centigrade. My SSD is 89.4, very similar to the AP since I'm mid-plane. My depth is 10.6, and my equivalent path length, again, if this was not a homogeneous calculation, is 10.2. Now, since I'm at the isocenter, my point of calculation is at the isocenter, my source to calculation point should be 100, but we can double check that. So we'll add 89.4 plus 10.6 gives me 100. So my inverse square factor for this particular beam is source to calibration distance divided by source to calculation point distance squared is 103. This makes sense. Both fields are treated isocentrically and calculated at the isocenter, therefore their inverse square factors should be the same. So I would encourage you to go through your data book and calculate the monitor units for these. And basically what you're going to end up with is a reference dose, 100 centigrade, divided by your collimator scatter factor and phantom scatter factors are both 1.0. Then you're left with a TMR and an inverse square factor.